Hello everyone, welcome to the product demonstration. So today we will be diving deep into the machine learning model development for stock market analysis. So we'll be going through this Python script as a snippet file so that we can understand what each and every snippet is going to do. So starting in the first line of the code, we can see what all the necessary libraries are there to complete this particular project. So PRAW is a Reddit API which can scrape the data from the Reddit. So and these are the libraries to create the data frame from the scraped data. And these are some of the libraries which we need to modify the data into so that it can be passed to a model to get trained. And some of the main libraries which are used for classification, report generation, and accuracy calculations and all. So these particular libraries will be helping us in developing the model. So first, starting with the code, I'm going to use a sentiment analyzer, which can help me in predicting whether the stock market related news is saying whether it is going up or it is going down. So that understanding the words, it can predict what it is being said. That's what the sentiment analyzer does. Now coming to the first part, scraping the data from the Reddit API. So as I said, we are using PRAW, Python Reddit API wrapper. So for that to be worked, these are the details we need to provide. So this is my client ID, and this is the secret password generated at that moment. And this is my user ID, which will be unique for each and every particular Reddit account holder. And this particular function here will help us to scrape the Reddit data. Here, if you can see, there is a limit called as 500. So I'm setting the limit to 500 so that it can scrape the first recent 500 articles or whatever the data is available within the Reddit. And to focus on what all the things we need to scrape, these are the main things that I wanted to focus on: stocks, investing, Wall Street bets, and all. We can even increase this if you want. So once we get the data, we need to clean it and pre-processing. All those steps will be involved, which will be covered under this part. So this is the pre-processing part. Removing the line text, converting into lower text, sentiment analysis, and all those things will be done here. And finally, we'll be vectorizing the data so that it can be transformed into a linear dimensional one, which can be helpful to be fed into the model to train it further. And this will be our final labels to predict whether it is an up movement or down movement based on the sentiment analysis which previously defined. So here we are splitting the data into two parts: training and testing in a ratio of 80:20. So 80% of the data will be fed into training and 20% will be fed into testing. So coming to the last part, this is our model architecture. This is a pictorial representation. It can be a bit complex, so that this particular snippet can explain you what the model build is. So first, as we have input layer, then I created two ReLU activation layers which will be passing further the input so that it can process it to be understandable by the model. Now we are reshaping the inputs which are being brought out by this dense layers. This is a particular main thing that we have to focus on: LST, long short-term memory, and this is a thing which will be changing complete picture of the model attention mechanism, so that it will look particularly into the points which will focus mainly to predict the sentiment of the particular text. And at the last, we'll be flattening it to get a single dimensional output, and this will be our output layer which can be shown in the last. So before passing the data into the model, we have to convert it so that it can be readable by the model itself. So that's why I'm converting here it into a numpy array, and here I'm training the model. As you can see, I have put 10 epochs with each epoch containing 32 batch size of a data frame. So this is how the input architecture is, model architecture. In each epoch, we can see the loss, accuracy, valuation loss, valuation accuracy. And at the final, in each and every model, we need a prediction and evaluation test. So these are the predicted variables. This will be saved in the microd variable. And this particular function helps us in plotting the loss, accuracy, and all those things, evaluation metrics to get a pictorial representation, which will be very clarified and easy way to represent everything. This is a classification report. So here we can see the two labels, target variables: 0, 1. 0 indicates down movement, 1 indicates up movement. And we are getting an accuracy of around 80%. And this is a graphical representation of the accuracy and the loss. So here the blue indicates the train loss. So it's starting from 70%. We have reduced the loss to 55%. And coming to the validation, it was below 55. So it's a better improvement when compared with other classical ML models and normal neural network architectures. So this is how LSTM can help us in doing the stock market analysis. Thank you.